Bayes method can update the probability after obtaining new information. It is the tool that helps us to update our beliefs when new data emerges. So naturally, it is not supposed to use once, but multiple times. The crucial part of Bayes probability is iteration. I'll show you how Bayes iteration works in this video. Let's see an example first. If there is a disease that affects 1 out of 1,000 people, and the screening test has a reported sensitivity of 99%, then someone gets a positive test result. What is the chance he really has this disease? Well, let's use Bayes probability formula to solve this question. We know that the screening test accuracy means if someone has the disease, the probability of having a positive test result. So PB given A is 99%. PA, the probability of the disease in the general population, which as mentioned is 1 out of 1,000 people, 0.1%. PB, the probability of test positive. First, how correctly test positive. Second, false positive, don't have the disease, but falsely identified. Plug all the numbers into the formula. We get 9%. Well, as you see, 9% result is far from ideal. But is that an useless result? No, because we can then do another test. If this time still gets a positive result, what is the chance he really has this disease? Use the Bayes formula again. This time, PA changes from the probability of the disease in general population, which is 0.1%, to the posterior probability of having the disease, which is 9%. This time, we get the result of 91%, much better. If you want to have a more close to truth percentage result, you can do more tests and use Bayes formula to update the result. I suppose you get the idea. Let's examine another scenario. This time, the screening test accuracy is 90%, and only those people who have the symptoms will go through the test. Among them, 5% have the disease. The screening test accuracy means if someone has the disease, the probability of having a positive test result, so PB given A is 90%. PA, the probability of the disease among the people being tested, which is 5%. PB, the probability of test positive, contains two parts. First, have the disease and how correctly test positive. Second, false positive, don't have the disease, but falsely identified. Now, let's put all these numbers into the formula. We get 32%. When given a second test to the people who has a positive first time, PB given A still 90%. PA, the probability of the disease rises to 32% based on the result of the first test. PB, the probability of test positive, contains two parts. First, have the disease and how correctly test positive. Second, false positive. This time, we get 81%. Hope you get the idea of how Bayes iteration works. Two takeaways. First, Bayes method helps us to update our beliefs when new data emerge. Second, the the crucial part of Bayes' probability is iteration. I'm always here at your service. See you in the next one.